Hi, my name is Ryan Fesler, and today I'll be explaining to you what happens to an underdamped second-order system when it's introduced to a step change of magnitude m. We'll look right here. The second-order system has a transfer function of y over x, which is the input or the output over the input. Right here you can see the equation. It's a function of zeta and tau, and also k. An underdamped system means their zeta is less than 1. We'll look here to the right. Our step change of magnitude m means that our x, our input function, is m over s. Since our system is underdamped and we're introducing it to step change of magnitude m, this is going to be our mathematical response. Y is our output. Now it's a function of t time because we took the inverse Laplace of it, and it's equal to this equation right here. Now we'll look at graphically what happens as we're introduced it to a step change of m. Because it's an underdamped system, it oscillates just like this. The closer our zeta value is to being 0, the more oscillations we have. So you can see here I label this one as 0.2 because it has a large oscillation and a small oscillation of 0.8 down here. This is an example. Our axis here is y, and this axis is t over z. Our ultimate value is going to be k times m. Next I'll explain to you some of the aspects of an underdamped system, and according to the graph, where you see these as the response happens. T of r is our time rise. Basically it's our time to where a response reaches the ultimate value for the first time. Our TP, our time to our first peak, is the time that it takes till we reach our first peak. Self-explanatory there. Our third aspect is our percent overshoot. Basically we know how much a response goes over our ultimate value compared to how long it takes to get to the ultimate value, A over B. Here it's represented as ultimate value to peak, and 0 to ultimate value is A over B. It's also equal to this equation right here. Another way to describe a response is by our decay ratio, C over A. As I showed you, A is the value that it's over. C is the second peak. So our second peak over first peak, how much it decays. It's also equal to that equation. Our last one is our period of our oscillation, just from peak to peak. It's equal to this equation. So today I've explained to you what happens to a second order system that's underdamped. When we have introduced it to step change of m, it's an oscillating system. Closer to 0, the greater response. Thank you.